Okay, now in our next video, Martha, Chad, and Thomas and I actually got the, again, Bob, okay? They're in a class. How many ways can I group them in pairs? Now, there's no first and second here, okay? Group them in pairs. So Martha, Chad, Martha, Thomas, Martha, Bob. Now, you just want them in pairs. So when we go with Chad, we don't put Chad, Martha, because I already have the Chad, Martha pair counted. They're not finishing in first and second place, okay? So I haven't put Chad with Thomas yet, and I haven't put him with Bob yet. Okay, now Thomas. Well, I put Thomas with Martha. I put him with Chad already. I just got to put him with Bob. And that pretty much is it. Because Bob would be next, but I've already put him with each of these. So that's 6, okay? Okay, so you say 6 pairs. Now, obviously we need a more efficient way to come up with that. During a basketball season, a school plays 12 home games. A teacher wants to attend 3 of these games. How many combinations of games can the teacher attend? So you go to Sioux Central, Newell, Pokey. That's 1. Pokey, West Bend, Mallard. I don't know. No, I don't want to say anything bad here on camera since this is going out. Pokey, West Bend, and St. Mary's. Okay, that's another combination. There's really no first, second, third here, okay? But you're not going to all 12, okay, obviously. Well, then it's just one possibility. So what we need to do is put the question mark, and this is why I did the question mark. You put 12. You want to attend 3 games, so there'd be 9 you're not going to go to, okay? Now, do you see the words first and third in there? No, you don't. So you're not going to protect him, okay? Then I use a C, a combination, okay? C stands for combination. And you can see it in the problem. It asks for combinations. Now, combination, the number of possibilities are smaller than it is for a permutation because permutation, again, back to this problem, you'd have to flip them back around if you had to rank them, okay? Here I'm just grouping them, okay? So obviously then I don't have to turn around and go Chad, Martha, Bob, Martha, you know, so I end up with a lesser answer. Well, that's why you don't protect that now, because when you go set up your division, okay, you divide by the 9 like you did in the last video, but you're also going to divide by the 3 factorial, okay, there. Now you're like, well, how do I do this? Well, obviously, it would be much easier to stop the 12 countdown at 9. A lot less work. 12 times 11 times 10 times 9, stop at 9, and then the 9s cancel. But then I need to divide by the 3 times 2 times 1. Now, there's a way to just do that on your calculator if you put the parentheses around the top and the bottom. Parentheses 12 times 11 times 10, close it, and then it'll calculate that product for me, divided by 3 times 2 times 1. Some of you are like, well, ain't that just 6? I know it's 6, okay? But it's not always quite that obvious. 220 is the answer. Now, here's how to label this. Not first, third. You don't see those words in there, okay? Combinations of 3. 220 combinations of 3. Okay? It's not as high of an answer. That's why we end up dividing by this product here. Herbson has 25 people in his math class. He picks 4 of his students to enter a cage fighting free-for-all. How many combinations of students can the man pick? Okay. So again, I'm just picking 4. I'm not saying you're first, you're second, you're third, you're fourth. Okay. So 25, 4. There'd be 21 that wouldn't go. And I don't protect this 4 because I don't see words like first, F-I-R-S-T, or fourth, F-O-U-R-T-H. Okay, so nothing's protected. Then I use a combination. So if I don't protect it, it needs to go in here, okay? Protect it means leave it out, okay? So I go 25 times 24 times 23 times 22 times 21. Stop at 21. Obviously, I'd much rather stop at 21 than 4. Okay, you can take your pick on where to stop, but logical to me, we'd stop there. 4 times 3 times 2 times 1. Put the parentheses. If you don't put that, this calculator thing doesn't work. And show your darn work. I don't like when people do this and then they don't. 12,650. Just put combos of 4. Write the word though. You can write the number if you want because you're picking 4. Okay, standard deck has 52 cards. How many 5-card hands can you be dealt? So 52, you can be dealt 5, so there'd be 47 you wouldn't be dealt with the question mark. Now we're not going to protect the 5 for the ranking because I don't see 1st, 2nd, 3rd, 4th, 5th. Okay, so again, that then is a C. Nothing's protected. So 52. And I have to divide by both these since I can't, the 5 is unprotected because I don't need to rank the 5. Factorials are all about ranking, and when you divide by a factorial, that means it's not ranked. So 52 times 51 times 50 times 49 times 48, stopped at 47. And then we number the 5, 4, 3, 2, 1. Okay. So parentheses 52 times 51 times 50 times 49 times 48. Okay. Divided by 5 times 4 times 3 times 2 times 1. Okay. 2,598,960. Okay, and that's all I have to say in this video. Okay, so again, now and there's going to be an assignment where the P's and C's are mixed together, so you need to actually, by the way, that I mean combinations and the permutations.